Okay, to finish up this section on linear inequalities in two variables, today we're actually going to be talking about systems. We talked about systems earlier in this chapter, and that was where we had two or more equations in two or more variables. So we found the solution to our system was where the two lines intersected. Well, today, because we're talking about inequalities, there's a difference in our solution set. So the solution set of a system of linear inequalities in two variables is the set of all ordered pairs that satisfy each inequality in the system. So remember when we had just a normal system, we had just one ordered pair. Well, now because we're dealing with inequalities and we have shading, then we have more than one ordered pair. So our solution set will always be a region on our graph. So really the only way to, or the best way to display the answer is always by graphing. So it's again just confirming what we've done before with lines and the shading. So you get some more practice in that, so hopefully that will become very easy for you. So every time you look at a system, the two main methods that we've talked about for graphing, let's write those down. The first one, we used intercepts, okay? And we used intercepts when we had A and B on the same side of the equation, generally called standard form, ax plus by equals c. Or we use the slope and the intercept, and that was when it was solved for y. And so we had y equals mx plus b. So you don't think that's a minus, let's put an arrow on that. Okay, so you really, every time you look at a line, you want to decide which way is going to be the best way for me to graph it. So I look at this first one, and I'm going to put a 1 next to it. So I'm going to go over here and write some things about it. X plus 2y is greater than 4. Remember when we graph that, we're thinking about the equation. Okay, and that looks like the first method, intercepts. So I'm going to go put 0 in for x and find y, and then I put a 0 in for y and find x. So when I put 0 in for x, that leaves me with 2y equals 4. And when you divide both sides by 2, you find out that y equals 2. So I have the point 0, 2. A lot of people are leaving it like this and not getting the, well, I'll tell you that in a second. Okay, so then on the next side, when I put 0 in for y, I have x equals 4. And this is what I'm saying. People go and graph the point 42, but it's not the point 42. They're intercepts. So you get the intercepts. The other thing that you ought to do before you graph it is go back and look and see whether or not it's going to be dotted or solid. This one's dotted because of our inequality symbol not having an equal. And then the other thing that we've talked about doing is putting in that test point. 0 for x and 0 for y. Is that greater than 4? If you need to simplify that. Is 0 greater than 4? That's false. So I'll make sure that I don't shade that region. Okay, now let's go to the second one. Okay, and in that second line, I'm looking inequality. I look first at the line. Okay, and again, x and y are on the same side, so I'm going to go find those intercepts. Put in 0 for x, put in 0 for y. So if I put in 0 for x, a lot of y'all are forgetting that negative right there. So I'm glad we have an example with the negative in it. When I divide by negative 3 here, then I find out that y equals 2, because negative 6 divided by 3, negative 3 is 2. And when I put in 0 for y, the negative's with it, so all I'm left with is 2x equals negative 6. Divide by 2, and I find out that x equals negative 3. Again, you do not have the point negative 3, 2. These are parts of the intercepts. Okay, then we're going to go back and look and see that our line is supposed to be solid. And the other thing we did was a test value. So 0 minus 0, is that less than or equal to negative 6? Is 0 less than or equal to negative 6? And it is not, so again, that's a false statement. So I'm going to go graph. I have um, 0, 2 on my y-axis. I have 4, 0 on my x-axis. My line is going to be dotted, so I'm going to go pick that, but I'm going to change the color so we can follow. And let's see if I can get through those. It needs to come down just a bit here. Okay, now after you do that, what I like to do, 0, 0 is false. So I'm not going to shade 0, 0. That means I'm going to shade this way. And I'm still in the line feature, so let's take that off and go back to my pen. So I'm shading this way. I'm not shading the point 0, 0. Okay, now I'm going to go and graph the purple one, which has the point 0, 2 as well, but it has the point negative 3, 0. So I'm going to shade, and this time I can actually go use this and just change it to solid, and we'll make it match our information. So it will be, and I didn't do a good job of matching that. Let me get those points. That's that point. Actually, that looks pretty good there. Okay, so I've graphed my solid line, and again, it's false, so I do not shade where 0, 0 is, and I shade the other side of it. And that means I'm going to shade this way. Now, when you're trying to figure out what the answer is here, think about the fact that we have 4 regions that we have now cut our graph into. I have a region here. I have a region down here, bounded by this line right here. I have this region here. I have this region, which I'm calling C, and I have that region, which is D. So I'm looking for the region that when I go to those lines, both those arrows are pointing that way. So hopefully you can see that that is this region here. And that's what I'm going to shade. I do need y'all to shade all the way to the lines and not pass, because what we're going into, it'll be important to find those points. So that is our solution. All right, so going to the next one, okay, helping you remember again. So we have 2 lines here. Our first line, remember when we have x equals 3, if it's x equals, then it's going to intersect the x-axis. And hopefully that's enough to tell you that's going to be a vertical line. It is going to be dotted because it doesn't say equals also. And if it's a vertical line and this is less than, then I'm going to shade to the left. Okay, and we can actually go ahead and do that one. So that means x equals 3. It's going to be a dotted line at x equals 3. So we've got this right here. And as we said, we're going to shade to the left. So that's going to point this way. Okay, and then if I go to the next one, the second equation that I have, I'm thinking of y equals -1. And if it's y equals, it's going to intersect the y-axis, and that will be a horizontal line. It will be solid. And so if it's horizontal, this is a greater than symbol, so I'm going to go up or above, whichever way you want to think about that. So we graph that. y equals O, but it's supposed to be solid. So let's go change that to a solid line. And as we said, we're going to shade above it. So you don't have to label your regions. I was just doing it to try to simplify things. But again, this is one region, or A, B, C, and D. And before I shade, I hope you can figure out that the region that we want is going to be region D, because that's the one where um, the arrows are pointing to when you're looking at the lines. So that is our solving systems of linear inequalities. If you have any questions about anything, please come see me.